Dear students, we were discussing in my previous lecture about the use of Laplace transform elementary functions on various derivatives which are included in the form of equation, that is differential equation, and that differential equation will be of ordinary and linear differential equation with constant coefficients. That differential equation will contain the functions on the right side like constants. It may be homogeneous, it may be containing exponential, it may be containing algebraic function, it may be containing trigonometric function, or it will contain combination of all these terms. We discussed already homogeneous function in the previous lecture and also the exponential term in the previous lecture. So, one such example, this one, y double dash minus y dash plus 2y equal to e to the power 2t. So, this is already discussed, and the next one, trigonometric function, today we shall discuss, and algebraic term also we shall discuss, and the right side with different types of initial conditions also will be given. Today we shall discuss like that, and equation containing some trigonometric function with the various types of the angles also will be discussed today. And as a final application, today we shall discuss with equation more than one time. That means two different differential equations which are linear and first order differential equations are given, and we call that type of system as simultaneous differential equations. Today we shall continue the problems which contain on the right side, that is with the homogeneous of higher order, trigonometric function, even algebraic terms on the right side, and various other functions. Now, another example if I take today, that is in terms of algebraic term and the exponential term which are multiplied together on the right side, and that becomes like this. The problem is solve x double dash t and plus 2x dash t plus xt equal to 6 into t e to the power minus t, and the values, initial values x0, it is x dash 0 equal to 0, it is given. Dear students, all these lectures were including Laplace transform direct application, Laplace transform inverse application, and various properties on direct Laplace transform, various properties on inverse Laplace transform, periodic function, next is unit step function, and finally, having understood all these topics in the Laplace transform, this is the case, these are the cases finally you are going to apply how to take out the solutions of particular differential equation when right side containing various functions. Now, this is entirely different type of the term on the right side we are getting. This is a product of algebraic term and the exponential term. In the previous lecture we learned when the right side was containing exponential term separately and homogeneous type means this part was 0. Today it is not 0 on the right side, and how to evaluate using Laplace transform by the application of transform of derivatives, that means Laplace transform on derivatives. Okay. So, we will proceed here. This system, that means the given statement includes x is a function of t, because here x double dash t, x dash t, they are all differential coefficients, and dx by dt will convey the meaning that x is a function of t. Therefore, we take Laplace transform on each term, that is L of x double dash t plus 2 times Laplace transform of x dash of t plus L of, it is xt, that is 6 is the constant, it is nothing to do with the Laplace transform, you can put it outside, that is t into e to the power minus t. Recall the expressions what you have studied for second order derivative, first order derivative, and the rule, that is in place of ft which takes as a product of algebraic term and exponential term. Here for the first term you must write that s square L of xt and minus s into, because you know that it should go on decreasing by one number, therefore s into it is x0 minus x dash of 0. All these three terms are responsible for the Laplace transform application for second order derivative, that is the first term. And the second term, 2 is to be multiplied for both, that is 2 times s, it is L of xt, and plus of 2 times means there is a minus sign in the formula, you have to write 2 times, it should be x0 plus L of it is xt equal to 6 times, what is the formula you have, that is L of t to the power n, it is f of t is equal to minus 1 to the power n, it should be dn of fs, it is ds to the power n. When algebraic term is multiplied for the original function, that is ft, then we call it as derivative property in the Laplace transform. That is, you have defined two properties of Laplace transform. This is the one, algebraic term L of t to the power n f of t is equal to minus 1 to the power n dn divided by ds to the power n, and it is operating on fs. There is another property, that is integral property, but here the term is multiplied to the function f of t, so that you have to go for derivative property, otherwise we call it as multiplicative property. Multiplicative means multiplication by algebraic term. Here, that is in the second case, f of t is divided by t, we call it as division property, otherwise it is called integral property. But in this present problem we are applying, that is the case of multiplication when algebraic term is multiplied, so that multiplicative property we apply. Okay, what is this f of s? This f of s is due to applying L to this ft, you are getting it as f of s. So here f of t is, that is e to the power t minus t, that is your f of t, then its fs is equal to 1 by it is s plus 1. Otherwise, if you take this t as the second term and exponential as the first term, we can also go for shifting property application. But as it is, if you want to process it, then it comes to be t is multiplied, so that multiplicative property you have to use. Because another option you can think like this, for if you are so particular about exponential property, then e to the power minus t into t, then this becomes f of t, then its fs is 1 by s square, then easily you can make out that is 1 divided by s minus 1 whole square. Here 6 is there, and then minus 1 you write as it is, and here n equal to 1 because t degree is 1, and dn means here also 1, that is ds to the power 1 operating on f of s, its fs is nothing but, that is fs means 1 by s plus 1. Now if you write this step, I am sure that mathematics problem solving statement is like this. If you understand the problem and if you write proper formulation, I am sure that more than 75% of the solution is over, because this step normally any evaluator will see, any evaluation process will be completely depending on what expression you are going to write and what formula you are going to write. Your presentation should be so good in LHS and RHS with all these details. Then what are your values given, initial values? This is 0 and x dash is 0, and here x is x0 of 0. You can easily collect the common coefficients which are explained like this: L of xt multiplied by what terms? That should be s square one term, plus 2s another term, and one more is plus 1, that is s square plus 2s plus 1 in the left side. And to take any term from the LHS to RHS, there is no term left, because initial conditions are given x0 is equal to 0 and as well as x dash 0 is also 0. So, you are left with no constant on the left side, so that you need not to shift anything to the right side. Only thing you have to discuss about the differentiation on the right side, that is minus 1 to the power n, that is n equal to 1. Therefore, minus 6 here and d by ds of 1 divided by s plus 1. Differentiation easily you can make out, that is minus 1 by, it is s plus 1 whole square. How we are going to differentiate? Because you have studied the basic differentiation is, this you can handle by two approaches. One is as it is, means u by v formula. This is ratio type, that is u by v, denominator s plus 1 into derivative of numerator is constant, it is 0, minus 1 into differential of denominator is 1 and divided by it is s plus 1 whole square. As a result, you are getting minus 1 by, should be s plus 1 whole square, right. So, this is the term you are going to write. This is one option. Another option easily you can think of when numerator is a constant. Therefore, it is d by ds of s plus 1. If you take this whole function to the numerator, it turns out to be like minus 1. Then its derivative. So, as it is, you have to write minus 1 into s plus 1 whole to the power minus 1 minus 1. It should be minus 2, and inside differentiation inside, because it becomes the composite function. Composite means function of a function. What do you mean by function of a function? First, you have to differentiate the make changes in the exponent, means it is a degree of that particular factor. This is the factor, that is s plus 1, its degree is minus 1 and the differentiation should be taken as minus 1 with another minus 1 according to the rule. It leaves the final coefficient as minus 2 and then differentiation inside. Differentiation inside means it is a linear term, s is the linear term, and the differentiation s to the power 1 minus 1, that becomes s to the power 0, that becomes 1. Therefore, it leaves finally minus 1 divided by that is s plus 1, minus 1 divided by s plus 1 whole square. This whole square should be in the denominator, because u by v formula, denominator square. Then finally it becomes 6 divided by, it is s plus 1 whole square. So, this is the right side simplification when you talk about the derivative property application for the whole product, that is 6 into t into e to the power minus t. Then what do you write for this quadratic function? Here it is a quadratic function, that is s square plus 2s plus 1. What you will write for this one? That is ax square plus bx plus c form. What is the coefficient then? L of xt multiplied by, it is s plus 1 whole square. If you expand it, s square plus 2s plus 1. That means you are given the answer, you have to write the statement. The statement is this. Suppose if you expand, you are getting like this. Suppose if you reduce this by with the summation of two terms, means it should be s plus 1 whole square, and right side it should be 6 divided by s plus 1 whole to the power 2. Then what we want is L of xt, you have to make this term as free from this multiplication. It is equal to 6 divided by s plus 1 whole to the power of 4. That means here already 2 is there, one more cross multiplication, it makes us 4. Then you have to go for writing the final statement, which gives the meaning as solution of the given differential equation. The solution is 1, whatever the function is there, without derivative, if you write, it becomes the solution. Then up to here you understand, where you are studying the Laplace transform, as we have been telling both the operators. Initially for the problem, that is in the equation 1 up to here, completely this part is with the Laplace transform application, remember. And later on, that means you have to apply Laplace transform, you have to apply Laplace inverse, and then you have to write for a final solution as the original function. That original function will be in terms of Laplace inverse, that is 6 divided by, should be s plus 1 whole to the power of 4. That is 6 is constant, you can put it outside. Then L inverse 1 divided by s plus 1 whole to the power of 4. Now you have to evaluate this one using shifting property. What is that shifting property? Because you do not have the ready-made formulation for this, that is 1 divided by s plus 1 whole to the power of 4 under the Laplace inverse. So that if you had like 1 by s to the power of 4, immediately you would have written that is algebraic term, third degree term, then applying Laplace you would have get in the denominator as fourth degree term. Therefore, from third degree to fourth and fourth degree to third, you have to think about the exponential property application. What is that? Then that is equal to 6 into e to the power minus t and then L inverse 1 divided by, it should be s minus 1, it is plus 1 whole to the power of 4. That means here L inverse of this much is equal to followed by exponential term when s is in between this step and this one, this step, s is changing to s minus 1, that is all. You have to understand the very secret term that you are going to replace is this much. You are changing s as s minus 1 to make this s plus 1 as only s. How it is possible? You have to see that other term is of which sign. This is with the sign as plus sign, so that opposite sign you have to take so that this 1 can be eliminated. Thereby this plus 1 minus 1 can be cancelled and you are getting the term that is equal to 6 into e to the power minus t, then L inverse and 1 divided by it is s to the power of 4. Then, so now it is very easy to write what is this 1 by s to the power of 4 in terms of t e to the power minus t. It is t cube divided by 3 factorial. That is by the formula again. What is that formula? You know about that one? L of t to the power n, because in one of the previous classes already we have discussed what is that algebraic term when degree is n, that is equal to n factorial divided by s to the power n plus 1. Then this can be written t to the power n is equal to L inverse n factorial over s to the power n plus 1. This also can be written t to the power n divided by n factorial is equal to L inverse 1 by it is s to the power n plus 1. Then what I did in all these 3 steps, the very important rearrangement we did, that rearrangement is nothing but that is t to the power n applying L, you are getting Fs, and this n can be shifted anywhere, either you can retain in the left side or you can shift it to the right side. Therefore, this is the statement given in terms of t, and applying inverse you are getting this value. So that here answer is given, that is s to the power of 4, here s to the power of 4. Then in terms of t you have to write means here n is there, here n plus 1 is there. Therefore 4 can be written as 3 plus 1. Therefore when 3 plus 1 is there, you have to write t cube and divided by its factorial, that is 3 factorial. What is 3 factorial finally? 3 factorial is 3 into 2. 3 into 2 means what? 6. That 6 already it is there, which we can cancel without any hesitation. We can cancel this 3 factorial with 6, and finally you are getting it as t cube into e to the power minus t is the final answer for that particular problem. Therefore, this is the initial value problem, means differential equation with initial conditions together will form as an initial value problem. We call it as IVP. Then this IVP can be solved. Even right side is algebraic term multiplied, that is t into e to the power minus t, applying this concept, and we are able to get this much, and right side applying Laplace inverse we are able to get this much. So this is the solution from L inverse, and this is the solution from Laplace transform, and these are the transforms of derivatives application. Let me take another situation in the same fashion. Another situation we will solve where the right side is 0 but left side is all the ordered derivatives are present in the left side. What all the ordered derivatives? One is, that is a third derivative I take, another one is second order derivative I take, and next one is first order derivative also I am taking, and that will be extended for next one more I will solve again, that is with respect to the fourth order derivative. So fourth order derivative, and third order derivative, both the situations we will discuss with the particular initial conditions. What is the third order derivative here? That is, fourth order is there. Fourth order I will take before that I will solve one third order derivative, then I will come back to the fourth order derivative. Let me solve this third order derivative one problem here. It is given like this: y double dash plus 2 y triple dash plus 2 y double dash and minus 2y dash and minus y dash minus 2y equal to 0, and the conditions are attached to this problem except one, that is y0 equal to y dash 0 equal to 0 and y double dash 0 equal to 6. This is another interesting situation where you have to deal with third order, that means higher order derivative. Previous problem was second order derivative. Earlier to that I took it as first order derivative, and now it is third order derivative. I will go for the fourth order derivative, then I shall discuss with different types of right side functions and trigonometric functions also I will involve probably in the next one or two cases. Now same time, but this is remember, this is homogeneous differential equation. Homogeneous means you know already that right side is 0. Therefore, in the solution part we take that L y dash y triple dash plus 2 times L y double dash minus L, it is y dash minus 2 times L of y, it is nothing but y of t, and right side L of 0. Remember, this L of 0 is nothing but you are introducing that value 0 inside the definition of Laplace transform. What is that? That is L of f of t is equal to 0 to infinity e to the power minus st, it is f of t dt is equal to f of s. Here L of 0 means this f t you are replacing here in this position as 0. Since it is a definite integral, you must know the basic meanings of all these mathematics formulations. If you are not strong enough in the basic formulations, then anyone cannot survive in the mathematics total discussions. You must know the basics and the basic formulations thoroughly, so that one amongst the basic thing is property of definite integrals. That means when the function is 0 in the definite integral, the value which we have proved in the theorem as 0. Therefore, L of 0 becomes 0, and here that means s cube L of, it is y of t minus s square, it should be y0, then minus of s into, it is y dash 0 should be y double dash 0, 2 times s square L of yt minus should be 2 times y of 0 minus 2 times y dash 0, that is enough, and minus should be s into L of yt and minus y0, that is enough. I think this is the first order derivative, and minus that is 2 times L yt, and that is equal to 0. I repeat, the application of transform of derivatives to all the terms in this problem consists of all the 4 terms. One is third order derivative, next one is second order derivative, next one is first order derivative, next one is without derivative. All the 4 terms this problem consists. Then individual term you have to apply its corresponding expression. That means this first term takes 1, 2, 3, 4 terms like this. If I put the floor bracket, I think it is better. So this is the part for the first term, and this is the part up to here for the second term, and this is the part takes 2 terms for third term, and this is the part for last term. Then what you have to do is you have to apply the initial conditions. Y double dash 0, this is the only term takes, that is 6, whereas all the other terms are with 0. That means y0 here it is 0, then y dash 0 it is also 0, and here y0 this must be, and y dash 0 that is also 0, and here y0 is 0. Now carefully take the correct simplification by making common coefficients from Laplace transform, that is L of yt, we can keep it outside, L of yt, which is multiplied by s cube, and next term is 2s square, this is one term, and next term is, this is minus s, and next term is minus 2. I hope so. This is, let me check it, this is s cube, this is 2s square with plus sign, and this is minus s, and this is minus of 2. I hope I will close the bracket. That is equal to, only one term you are finally left with, because the initial condition for second order derivative is not 0, whereas other two values are 0. Therefore, this minus 6 I am taking it to the right side, that is equal to plus 6. That is all. Then what is your L of yt? L of yt, you have to shift this function to the right side, that should be 6 divided by, and your ordinary simplification must take all these terms to the denominator, minus s minus 2. Now this situation takes in the denominator, it is a third degree equation, because when you come across the quadratic equation easily we can manage, but when you come across third degree equation you have to write the factors properly. Normally your first inspection method, that means we call it as an inspection method, you have to group the terms like first two terms and second two terms. From the first two terms, whatever the factor it leaves, if the same factor repeats from choosing the third term and fourth term, easily you can combine those two factors and you can write it as product of those two factors. If it is not so, for example, then you have to go for synthetic division method. What is that synthetic division method? Then you have to define this total quantity as a function of some s, then go on giving some trial values like s equal to 0, for which value you are going to assign that equation satisfies, then that itself will become as one of the factors. Then divide that total function, and then when it becomes the first factor, and the remainder which you are going to take, so that will be acting as one another coefficient. But here I hope fortunately first two terms you are getting like this, that is 6 divided by s into, should be that is s square if you take common, s plus 2 one factor, and minus if you take common, that is s plus 2. I think fortunately we have the common coefficient, and finally we are going to write this one as, it should be s square minus 1 is one factor and s plus 2 is another factor. This is called something like shortcut method we apply, shortcut method, but this does not hold good in almost general cases. This is only some peculiar situation where you can rearrange like this. If it does not happen, then ultimate method is you have to go for synthetic division method. Here it is not necessary, I feel, and directly you are getting the factors. Next, the next part is, this is a second degree again. So this has to be converted like first degree, it is possible, that is 6 divided by, it should be s plus 1 into s minus 1 into s plus 2, that is, what is the highest degree you found in your expanded form? That is s cube plus 2s square minus s minus 2, and the simplification comes to be 3 factors, and the highest degree when you multiply from all these 3 brackets, that means if you release and you are getting it back as, that is third degree equation, third degree term, second degree term and first degree term, and then finally 1 minus 1 and 2, you are getting finally, that is plus into minus minus and minus into plus minus, leaving minus sign, 1 into 1 into 2, that becomes 2. Therefore your rearrangement is pakka and it is correct. Therefore now you have to go for, that is L of yt should be evaluated for inverse. This comes to be, what I was trying to convince is, up to here all that procedure we have applied we have taken the Laplace transform direct application. Now, this step which I am going to write now, this is the case of inverse Laplace transform. All that knowledge what you are gained from, that is your basic definition of Laplace transform, that is L of E of t is equal to 0 to infinity e to the power minus st, it is f t dt. This is one symbol, and another symbol L inverse of, it is f of s is equal to f of t. What you are doing is, up to this step, this is the part you have applied, and from here onwards, this is the part you are going to apply. You must keep that in your mind when you are solving these differential equations, because the main goal of studying this Laplace transform in this field is especially for the engineering problems. And today also I am going to end up my lecture with one important application for graphical explanation, that is for unit step function concept, that is especially for wave propagation. I will end up with that particular application problem. Now, in any differential equation, two things will play major role. One is direct application, next is inverse application. In between, when you are talking about direct application, all the elementary properties will have to be remembered. When you are talking about inverse application, corresponding elementary properties are to be involved. Combination of these two will leave the final answer as y of t, which happens to be the solution of the problem. Yes, what is that next? Yt should be, shifting that operator to the right side, should be L inverse 6 divided by, it is s plus 1 into s minus 1 into s plus 2. Since you are coming from diploma stream and you need to know regarding some partial fractions, because we being the teachers, maybe we can give one or two examples in the available time, but you have to learn, you have to understand these concepts and try to apply for more number of examples, because the secrecy of mathematics is like that. When you go for more number of examples and more perfection you will get, for especially for the concept or formulation. Yes, here it is the case of partial fraction which you have to discuss at the end. It is very simple. If you had not studied partial fractions earlier, and you can easily plan for partial fractions understanding, that is there are only 2 or 3 rearrangements in the partial fractions that you have to understand how to resolve into the partial fractions when product of some factors are given. The product of factors means you will find only 3 situations. One is like this. This is the case of linear, linear, linear. Another case is linear with quadratic. Another case is quadratic and quadratic. Like this you will find the situations in the products of the denominator. Okay. So, now by partial fractions, that means 6 divided by, that is otherwise 1 divided by, if you keep this 6 outside, s plus 1 into s minus 1 into s plus 2 will be written as a divided by s plus 1 plus b by s minus 1 plus c by, it is s plus 2. And when you are working for this particular step, you have to take the LCM, that means on both the sides. LCM is already present in the left side, but right side when you are working about the LCM, carefully take the division, that is 1 is equal to a into s minus 1 into s plus 2, because common LCM is a product of 3 factors. So, when you divide it, one term will cancel, remaining 2 terms are written, plus b into s plus 1 into s plus 2 plus c. C takes what multiplication? S plus 1 into s minus 1, this is going to be divided. Now, so here also on the right side is product of 3 factors, left side is product of 3 factors, we are cancelling it. Then 1 remains in the left side, and this is the part in the numerator on the right side. All that we are doing only for finding the values of the constants. Then what are those values? Now directly we can put at a is for calculating the constants a, b, c, and whatever these values are there, opposite values you give. Then at s equal to, the first factor is plus 1 is there, you put it minus 1, and s equal to minus 1 is there, you put it plus 1, and s equal to plus 2 is there, you put it minus 2. Respectively, 3 constants directly you are separating, and left side you have more advantage. Left side is only the constant which is not containing the term as s. Therefore, s equal to 1 in the left side will not change because constant, only it contains constant, there is no s, so that it remains to be s, it remains to be 1 only. And right side, when you are talking about s equal to minus 1, wherever s plus 1 is there, that term becomes 0. Here s plus 1 and here s plus 1. That means this whole product is 0 and this whole product is 0, but this is not 0. What is the value you are getting? Then s equal to minus 1 means minus 1 is minus 2, and minus 1 plus 2 is plus 1, and this is minus of 2a. Then a is equal to minus 1 by 2. This is your calculation. This is what the basic compulsory steps which you have to learn in partial fractions. Now s equal to plus 1 means this term becomes 0 and this term becomes 0. Plus 1 means 1 plus 1 is 2, 1 plus 2 is 3, 3 into 2 is 6, that is 1 is equal to 6 times of b. Therefore, b is equal to 1 by 6. Then s equal to minus 2. S equal to minus 2, this is 0, this is 0. S equal to minus 2 you are putting, that is minus 1, minus 2, minus 1 is 3, minus 3, then minus into minus, that is plus. Therefore, 3 times of c. Therefore, c is equal to 1 by 3. When once you got all these 3 values, you substitute in place of ABC, that is, if I take this 6 outside, then a divided by s plus 1 means a equal to minus 1 by 2, that is 1 by 2 divided by s plus 1, and b is 1 by 6, put plus sign, 1 by 6 divided by s minus 1, and c is equal to 1 by 3 plus 1 by 3 and divided by s plus 2. With this, individual Laplace transform operator is to be operated. What is the first term on the right side? That is L inverse of minus 1 by 2. You must put minus 1 by 2 as it is. This must be exponential term e to the power minus t. Already you are much familiar with this. And plus 1 divided, because it is an exponential term, 1 by 6, and e to the power, when minus is there, opposite sign plus t, when plus is there, opposite sign minus. Then plus of 1 by 3 and then e to the power minus of 2t. So this is your final answer for the solution of homogeneous differential equation. Homogeneous means right side is 0, and the differential equation is with constant coefficients and it is said to be linear. Now I will give the next very important case which I will end up by taking higher order derivatives before I step in into the application problem, one final application problem. Now the next problem is, you can easily make out, that is y to the power of fourth order derivative minus k to the power of 4y is equal to 0, then y0 is equal to 1, then y dash 0, y double dash and y triple dash 0 is equal to 0. This is commonly occurring another very important situation. This problem you must solve, and this type of problem you have to repeat, because when you have the discussion of slope in terms, that is a slope means in terms of derivatives, especially when you have the plotting of curve at different locations with respect to the slope, means first order with one location, that means once displacement you will explain the interpretation of that particular derivative, and if it is a second order derivative, then the slope you will notice at 2 locations. If it is a third order derivative like this problem, this is third order, means you will plot the curve at 3 different locations by interpreting the slope of that particular plot. The graph means for this solution, that is yt. What is that? Yt means you can plot the graph. How to plot? T values and then yt values. So when you go on giving t values like 0, 1, 2, 3, 4 and so on, then in the coordinate system you can plot the curve. Then that curve should be discussed at the 3 different locations, that is third order derivative, up to third order derivative means slopes you have to discuss. So another important situation which I am going to discuss now, the fourth order derivative problem, that is you have to solve higher order equations, then lower order you will find more comfortable when you solve more number of situations of differential equations that means more number of problems means more with a higher order derivative. For example, in this case, that is y fourth order derivative minus it is k to the power of 4y equal to 0. This is the problem. That means this is fourth order derivative minus k to the power of 4 y, that is equal to 0. That is equal to 0 means what do you mean? Right side when it is 0 means it is a homogeneous differential equation. Yes, your k here, that means k, this one coefficient of y, this acts as a constant. It is not a variable, but y to the power of 4th means it is a dependent variable with the fourth order derivative. So the conditions are except the first one, like y0 is equal to 1, whereas y dash 0 minus y double dash 0 minus y triple dash 0, sorry, these are all equal to, they are all equal to 0. It is given like this. Yes, you accept this data in terms of your own familiar symbols. What is that familiar symbols? It is d to the power of 4y divided by dt to the power of 4 minus k to the power of 4 y of t is equal to 0. It should have been given like this. This is fourth order derivative minus of constant to the power of 4 and yt is equal to 0. Then you are taking on this Laplace transform, y to the power of fourth order derivative minus k to the power of 4, you can put it outside, and L of it is yt, and right side it is L of 0. Then left side first term, it is a fourth order derivative. You have the general formula like y to the power n. When n is equal to 4, you have to apply s to the power of 4 L of yt, you have to write like this, and minus s cube y0 minus s to the power of 2 y dash 0, next minus s to the power of 1 y double dash 0 minus s to the power 0 and y triple dash 0. So all these 5 terms, 1, 2, 3, 4, 5, all these 5 terms are due to fourth order derivative, minus it is k to the power of 4 Lyt, and right side as usual you know that when the function is 0, according to the definition of Laplace transform, the whole value becomes 0. Now what are we talking about? Next is application of initial values. Application of initial values means except y0 is equal to 1, this is the only term which becomes non-zero, whereas all these values, all these terms will be replaced by 0. You are finally left with L of yt, what is that? S to the power of 4 minus k to the power of 4. This is the term and this is the term. From these two terms you can write as coefficients, that is s to the power of 4 minus k to the power of 4, and only the term you are left with minus of s cube because of plus 1, that is equal to 0. Yes, your problem has been reduced to this much. Now L of yt is equal to, easily you can write without any hesitation, s to the power of 4 minus k to the power of 4. What is your yt? So then yt becomes L inverse should be s cube divided by s to the power of 4 minus k to the power of 4. What is this further? That is s cube divided by, should be s square plus k square into s square minus it is k square. So you have got two quadratic factors which I was explaining regarding the quadratic functions. Now you came across that quadratic function. Okay, further what we do here, that is s square minus k square, it is also possible to write in terms of linear factors, because this quadratic factor with the minus sign, you can also go for linear factors. Those linear factors means y of t is equal to L inverse, it is s cube divided by, it is s plus k into s minus k into s square plus k square. You can put like this, then s cube by partial fractions, s plus k into s minus k into s square plus k square will be further resolved into partial fractions in this way, that is a by s plus k plus b by s minus k plus this is a quadratic factor. How we are going to write? If you have not studied earlier, then what I was telling is like quadratic and linear. Quadratic and linear means whenever linear is there, one constant you assign in the numerator. Whenever quadratic is there, two constants you have to assign in this fashion, like cs plus d you have to assign. This is the procedure as defined in partial fractions, that is whenever you have quadratic term which is not possible to factorize. Then left side, if you take the LCM, s cube is equal to a into s minus k into s square plus k square, one term, plus b into it is s plus k into s square plus k square plus cs plus d into should be it is s plus k into s minus k. Then as usual, when you recall the previous one or two cases already we discussed for applying the Laplace transform with partial fractions, opposite values you have to give. First one, at s is equal to k, one value, and at s is equal to minus k another value, and remaining those two we will take in a different comparisons. Okay, at s equal to k means this term becomes 0, and s equal to k means this term becomes 0, whereas s equal to k here and s equal to k here, this middle term is not going to become 0, but left side what is that? It is k cube, left side it is k cube, this is 0, and k, s equal to k means that is k plus k 2k, that is b into 2k and 2k square. What is that you are getting? That is k cube is cancelled with k and then k square, that implies b is equal to 1 by 4, that is 2 into 2. Now s equal to minus k you are giving, s equal to minus k means that is in the left side is minus k cube and on the right side minus 2k, that is minus 2k into b, and s equal to minus k whole square becomes plus k square, that is 2 into k square, and what you are putting minus k. So this becomes 0 and this becomes 0. Therefore b value, I think first term, that is not b, this is a, and a takes the value, already we have calculated b, then a takes the value, that is k cube, once again you are going to cancel this one, and minus also you are going to cancel, that also becomes 1 by 4. Therefore a equal to 1 by 4 and b is equal to 1 by 4, and finally you are left with another two constants, which those two constants will have to be discussed by comparing the coefficients on both sides, because they are not linear factors which you cannot assign the values directly. That means like this, if you take the comparison, what that particular comparison you have to make like this, that is s square means when you take the coefficients of multiplication. For example, here s cube coefficient in the left side is 1 and s square into s, that is a, one term, and here s cube you have to collect, and here s cube you have to collect, you will get one equation in terms of three constants, but already two we have evaluated, so that another one constant easily you can separate, and then you work out that one. For example, that is yt is equal to L inverse. So a divided by, what is that a? A is equal to 1 by 4. So 1 by 4 divided by s plus k plus of 1 by 4 divided by s minus k. Suppose you are going to calculate the values of c and d. Let me write the answer in terms of c and d only, plus c into s by s square plus k square, and plus d into, that is d into 1 divided by s square plus k square. For example, this is, you have to calculate the, because I did not calculate these two, you have to compare the coefficients according to what the explanation I have given, right. The first term 1 by 4 e to the power minus kt plus of 1 by 4 e to the power kt, and if s is not c is not 0, then if c is not 0, then it should be cos of kt multiplied by c, and plus if d is not 0, then d into that is sine of it is kT and divided by k when I am claiming like this, C is not equal to 0, D is not equal to 0. I do not know, because in the comparison you will get the answers. If any one of these two is leading to 0, then eliminate that term and write the answer in the presence of other term. Both will not be 0, you remember, at least one of those two constants will not be 0 and another one, if it becomes 0, remove one term and then add one more term. So with this I would like to stop up to here, and dear students, I would like to summarize all these things. Learn what is the meaning of Laplace transform, what are the elementary Laplace transforms involved and how you are going to derive them, and what is the inverse Laplace transform, how elementary inverse Laplace transforms, properties and theorems which you have to learn, and this one convolution theorem in the inverse Laplace transform, and unit step function, and finally understanding all those topics. This is very important, that is solving the differential equations. You learn all these things and go for more number of examples which you are, if you are going to solve, then you will get more perfection in this one. This is one topic where you can make it so easy and can score maximum marks in this topic. With this, any questions are there, I will be able to answer. You can ask the questions.